And then this one would have to go like here. And then this could go like there. Just like that. And then that would probably work too. I'm not 100% sure though. That's not a good design though. There we go. That turns on. And it
What if I
turns
said
off.
it this
Still
way?
works.
If you were to make like a truth table almost, it would be for an XOR gate, if A or B are in the true value, then the output will be true. But if both A and B
Yeah.
or neither A or B work, then it
It's
output is nothing.
A. I guess it would be A or B and not A and B. If that makes
Yeah,
any sense.
it's like I'll just say one is true, zero is false. If A equals one or B equals one, then it's true. But if A equals zero, B equals zero, or A and B equal one, then it's false.
I lost it. Whatever. Okay.
If they're both off, then it doesn't work. If they're both on, then it doesn't work. But if only one of them works, then the output's true.
Yeah. So
Yeah.
what you could do here for an XOR gate or an XNOR gate, which doesn't really make sense because it's nothing to do with NOR. It's like not XOR, and you just have a NOT gate at the end, and now it's on if both of them are the same. So if you turn one off, it's off. But if you turn the other one back off and they're the same, then I need to put these switches in the right.
So they both have to be on or off for it to
So
work.
if the switches here are facing the same way, and which means that the currents are the same, then the output is on. So you could actually use this to test if numbers are equal to each other. If you had a bunch of them and you tested one for each digit, then you could use this circuit to test if they were equal to each other.
I see.
Yeah. In binary, of course. So
When I
that's
hear
some.
binary, when I hear when I hear binary, I think of a binary operation.
Do you know what binary is?
There are many definitions. It could be computer code binary. It could be a
Right,
binary
I've asked you this before, haven't you?
Yeah,
You know,
I was
kind
about
of
to say
the.
I'm an algebraist and I work in abstract. When you say binary, I think you pair a set G with a binary operation star, and it's a group if G works with if the binary operation is closed and whatnot. Yeah, it's confusing shit.
Oh, I know a better way to show you binary. The values for binary. I could use my 7SD right here. So I have the signs all set up and stuff. So don't worry about this in here. Just watch the input and the output. So binary, to get what it is, you basically add this lever here that I'm standing on is worth 1. And then this one is 2, this one is 4, this one is 8. Then this is just the on and off lever that turns on and off the 7-segment display. Don't worry about that one. So yeah, so if I put this one on, that means it's worth 8 more.
Okay,
Right?
I'm
So
gonna
1 plus 8 is 9. What'd you say?
go to the output and see what happens.
So yeah, it's on 9 right now.
Hit 2 and 4.
4.
2 and 4.
Oh, hit 2 and 4.
Yeah, yeah.
I see. So that would be a 6, right?
All right, so this is an addition calculator.
No, it's not. It's a 7-segment display. It's taking a binary input, a 4-bit binary input, and showing you what value it is.
I see. So it's not actually
so
doing addition. It's just doing a
not
binary.
actually doing addition. It's just converting half a byte into what the value is. So if I put 2 of these beside each other, then it would be the levers would be worth 1, 2, 4, 8, 16, 32, 64, 128, respectively.
That'd be pretty big. It's a lot of
Yeah.
bytes.
The maximum value you can have in a byte is 255. Have you ever seen that number before?
255, yeah.
Yeah.
Heard that number more than once.
Yeah, that's why in games the maximum for some things is 255, and you're like, that's so random. Why is it that number? It's because it's when you have it that number, it only takes up 1 byte.
8 bits in a byte. That's what I remember.
Yep, that's exactly right. So this is all
Or
junk in here
I'm
that
more of a
makes it.
Java programmer.
Oh, nice. So do you think you could make world edit scripts and stuff?
Right now I'm like the Java programming class I'm doing. I'm just making a rock paper scissors game where you choose rock paper scissors and the computer makes its choice. But I'm on like version 4.0 now where it's like really interactive and whatnot. Writing a world edit thing now I just use MC edit basically. I just make a world, explore some chunks, and then I can use MC edit to do anything I want. Like literally, if I want to like delete an entire chunk, I can.
But I just sort of am needing a thing that will replace blocks that are not a certain type.
Oh, I wanted to show you this. I might as well while I'm at it.
I'm
I
just
did
gonna
this
pause the recording. Okay, I thought of something we could do. We could do a bit. How would you store a bit? Just like this. See how one side is on, the other is off? Now if I apply current to this side, it switches it. And no matter what I do on this side, it doesn't change again until I apply current on this side. And then it switches it. And it holds the bit. It holds its state until you change the other side.
I see.
Yeah. So if you do that,
Oh, I turned it off. About that.
if you do that, and then you take both of them off at the same time, it'll go into an infinite loop, which is bad.
It doesn't sound like a good thing, believe me.
Infinite loop. So yeah,
Doom.
So if we did this, watch what happens. The torches will burn out. Or not. It just chooses its preference. I see. Oh, very nice. Very funny. Ha ha ha.
You found out the secret now.
Oh no, that wasn't good. Uh-oh. Okay, I got this. Okay, now switch it. What the heck? Okay. It does not go into an infinite loop on Minecraft. But on Logic Simulator programs, it does.
I don't think Minecraft could handle that. That's the whole point.
Yeah, so if I just open up a Logic Simulator here, I wonder if I can even see this. Gates, nor. So, yeah, I have a Logic Simulator program called Logisim. Logic Simulator, Logisim, pretty simple. So I'd recommend downloading it if you like this stuff.
It basically tells you the requirements for certain logic operations.
No, it simulates actual gates.
Ah, I see. And then you figure out how to run it with Redstone.
Yeah, I have made calculators in it. Like multiplication, addition, subtraction. I haven't conquered the art of...
Do it on left coset multiplication.
Okay.
Do it on left coset multiplication.
What?
Do it on left coset multiplication of abstract abelian groups.
Of course. I don't know anything.
So, there's only 144 abelian groups we know of, so.
Of course. Like I know that.
It's actually pretty simple once you get to know it.
Alright. So yeah, I guess I could show you a pulse limiter. Pulse limiters are pretty cool. So you have your pulse coming in, right?
Showing.
And then repeaters can take the current out of a block with current on it, or going into, or I think on it. I don't know about going into it actually. I'll test it out right here. Does it work? Yes, so a repeater can take current out of a block that is being powered, but redstone cannot. Crap. That was bad. Okay.
Swimming pool, yay! Oh shit, now I'm under the world.
Good luck getting back up. Alright. So redstone cannot take power out, but a repeater can. That's really cool. I did not know that. Okay, so we don't actually need this thing on top. We can actually just do it like this, but we do need this one on top right here. And then this is a pulse limiter. You have to have this on the second setting at least for 1 tick. And then for 2 ticks, you have it on the 3rd setting. For 3 ticks, you have it on the 4th setting.
Right, explain a second setting for a redstone. What are the different settings?
Right. I haven't explained that yet at all.
Daytime. Yay.
So look at this. Each setting represents 1 tick. So if I have this nice lever, and then like this, and then on the 2nd setting, 3rd setting, 4th setting, and then I have a little thing like this for each one. And then, so now, you see they turn off sort of in
order.
In order.
So it's like a delay, almost.
Yes, so the higher the value, the longer the delay.
I see. Very intricate. So this is how you can make a musical machine, by having them hit the right times.
I guess, but it would be easier to just have them in series instead of parallel.
Dude, I've always thought we should somehow make a huge thing to play Jailhouse Rock. Buck and I tried, and we got the very beginning of it, but we can't get the whole thing to go.
Let me just show you another thing about repeaters. So, 4 repeaters on the 1 setting is equal to 1 repeater on the 4 setting. Exactly.
Yeah, it should. That should make sense.
It makes sense, right? Look at that. They turn on. They turn on, and then turn off at the exact same time. That was loud.
My mic is built into my computer, so that's why. I just talk at my computer. That's how it worked.
Yeah, so that is pretty well redstone basics. So yeah, do you know more than you did before?
Oh, I know more now. Now, let's create a huge space of land and let's make this Jailhouse Rock machine. I want to do it.
Hello, this is White Mamba with Redstone Tutorials, and I thought of a good design for, or rather not good, but compact design for an XOR gate. So this is the fast regular design. As you can see, when the output is on, when the inputs are different. The same goes for this one. One is on, the other's off.